Welcome to Summarize Science. For hundreds of millions of years after the Big Bang, the universe was dark and filled with a neutral hydrogen fog. But then, something incredible happened. The first stars and galaxies began to shine, producing powerful radiation that burned away that fog in an event called the epoch of reionization. For decades, a key question has been, what kind of galaxies were responsible for this cosmic transformation? Thanks to the James Webb Space Telescope, we're getting answers. A team of astronomers using the EXCELS survey pointed JWST's powerful spectrograph at 159 distant star-forming galaxies, some seen as they were when the universe was less than 1 billion years old. Their goal was to measure something called ionizing photon production efficiency, basically, how good these galaxies were at creating the specific type of high-energy light needed to clear that cosmic fog. To figure this out, they looked for clues in the galaxy's light. One of the strongest clues they found was in a specific color of light emitted by hydrogen, called H-alpha. As this chart shows, they discovered a clear trend. The stronger the H-alpha signal from a galaxy, the more efficient it was at producing that universe-lighting radiation. This signal is a direct fingerprint of massive, young, hot stars working overtime. They saw a similar, though slightly different, relationship with light from ionized oxygen, known as O3. This again points to very specific and extreme conditions inside these early galaxies, which were perfect for creating ionizing light. Another important factor was the galaxy's overall color in the ultraviolet spectrum. The researchers confirmed that galaxies with bluer UV colors, which indicates younger stars and less dust, were also significantly more efficient ionizers. Interestingly, just being a bright galaxy in general wasn't a great indicator on its own. The relationship between a galaxy's overall UV brightness and its ionization efficiency was weak, settling a long-standing debate and showing that it's not just about size, but about the type of stars a galaxy contains. But what about the outliers? The team noticed that some galaxies didn't fit these trends perfectly. When they investigated, they found a common culprit: dust. Galaxies that appeared to be superproducers but didn't fit the mold were often extremely dusty, which can trick the measurements. This is where the real breakthrough happened. By creating a model that combined all these factors, the strength of the H-alpha light, the UV color, and the amount of dust, they could predict a galaxy's ionization efficiency with remarkable accuracy. This left very little scatter, as you can see by how tightly the points hug the one-to-one line in this plot. This amazing visual shows the result of their combined model. Each colored line represents a different level of dust or UV color, demonstrating precisely how these ingredients work together to determine a galaxy's final ionizing output. So, what's the big takeaway from all this? The researchers have essentially discovered the recipe for a reionizer galaxy. The key ingredients are strong signatures of recent, massive star formation, a blue UV color, and a clear view without too much dust getting in the way. This study provides a powerful new toolkit for astronomers. Now, they can look at new images from JWST and, using this recipe, accurately estimate which galaxies were the true pioneers that ended the cosmic dark ages and lit up our universe for the first time.